right, guys, we are going to pick back up on those notes we had started last week when we were dealing with radicals. Today we're going to look at multiplying radicals. If you did fine with simplifying a basic one, you'll be fine with multiplying. Multiplying, what we're allowed to do with them is, as long as they are both underneath a radical, we can go ahead and multiply them together. So radical 5 times radical 3 is radical 15, right? Same radical, they're underneath radicals together, we can multiply them. Right, so then after you multiply, then you can do your factor trees and try to find those pairs, right, the couples that come out. So for the first one, radical 6 times radical 15. So anytime you have a multiplication problem, we want to multiply them together first. So 6 times 15 is radical 90. Now, some people will ask, well, like, why do I have to multiply them together first? Well, sometimes when you multiply them together first, they become a perfect square, and then I don't have to do a factor tree, and I can just tell you what it is. Okay, so sometimes it makes it a little easier. All right, so then radical 90, is that perfect? No, so then we can do our factor tree from there. So I'll go 9 and 10, 3 and 3, and then 2 and 5. And then I'm looking for pairs. So what do I have a pair of? 3s. That means A3 comes out. And then what do we do with leftovers? Inside. Leftovers in the fridge will go in as a 10. All right, so again, if you're not sure if you did it right, you could type the original problem in your calculator, see what you get as a decimal, and then check your answer in the calculator and see if it's the exact same decimal. And it should be. Okay, so anytime you're not certain, you can go ahead and do that. All right, number 2. So 2 radical 10 times radical 32. Where's that 2 going to go? Yeah, he's still outside. He's an outside number. Then I can multiply my radicals. 10 times 32. 320. I knew what you meant. Is 320 perfect? No. If you type that in your calculator, does it give you a nice, pretty answer? No, it gives a big, ugly decimal. All right, so that means I need to do my factor tree. I'm going to go 32 and 10. You can break yours apart any way you want. That was just the easiest way for me. All right, 32 is 2 and 16, 4 and 4, 2 and 2, 2 and 2. 10 is 2 and 5. Again, does it matter how you break down your radicals? No, doesn't matter. You end up same spot. All right, looking for pairs. All right, I got a pair of 2s, comes out as a 2. There's another pair of 2s, comes out as a 2. I have another pair of 2s, comes out as a 2. I have a leftover 5, leftovers in the fridge. And then don't forget you got this guy out in front, right, that was there to begin with. He also was outside. 2 times 2 times 2 times 2 is 16. A lot of you said 8 right there. Basic math is hard. It'll be the ongoing joke all semester long. Basic math's hard. How are we doing so far? Pretty easy? Number 3, there is a negative number and there's parentheses. Whoa. Does it make a difference? No. What do I do with that negative 2 and the 5, the outside numbers? You multiply them. Negative 2 times 5 is negative 10. And then I have radical numbers. 6 times 18 is 108. Okay, the fact that there's parentheses around all of that is no different than the other problems had a dot, right? We can show multiplication with a dot. We can show multiplication with parentheses. It doesn't matter. All right, 108 is not perfect, so we'll do our factor tree on that one. So it's going to be like, I'll go 2 and 54, 2 and 27, 3 and 9, 3 and 3. What do we have pairs? Of what? 3s and 2s. So pair of 2s, pair of 3s. I have a leftover 3, And don't forget the outside guy that's already there to start with. Don't forget to bring that one down. Negative 60, radical 3. How do I check my work to make sure it's right? Ask my calculator. You can just talk to your calculator. Whoa. Save you time, right? But yeah, type in the original problem, see what it is. Type in your answer, see what it is. They should be the same decimals. Very true. I mean, I talk to myself all the time, but I respond. I always answer myself. All right. Let me hop and skip and jump a little bit because I think we're doing all right. Let's look at number 6. Sorry, overachievers. I'm jumping to 6. Those of you who were working ahead. Number 6. There's a 2/5 in front of my parentheses. What do I assume that is? It's just a number, right? Don't freak out because there's a number that's a fraction, right? Fractions are just numbers. So I have a 2/5. We can still multiply those numbers under the radicals together, right? So we get 2/5 and then radical 450. Is 450 a perfect square? No. All right, so we can go ahead and do our factor tree. I'll go 45 and 10. Again, does not matter. All right, and then do you have pairs? Yep. Got a pair of 3s, pair of 5s. I got a leftover 2. And then out in front, I had a 2/5. Don't panic, a fraction is just a number. If you are somebody who is terrible with fractions, it's okay. I let you use a calculator all the way through this class, so don't panic. So 2/5 times 3 times 5 is, it is 6. So 6, and then a radical 2. All right, questions on multiplying? Awesome. Next thing I want to look at then are your imaginary numbers. Oh, have any of you worked with imaginary numbers before? One person? All right, imaginary numbers. I love this cartoon. Ooh, that's a tricky one. You have to use calculus and imaginary numbers for this. Imaginary numbers, you know, 11, 30, 12, and all of those. Okay. Are those imaginary numbers? They're made up? No? All right, so I'm going to show you guys a video. I apologize, it is not the most exciting. It's very short, but it gives a very nice description of what imaginary numbers are and like what they are used for in the real world. Okay? Good. It is the square root of negative 1. So I equals the square root of negative 1. So what's I squared equal to? Oh, I heard 1, I heard negative 1. I'm scared. Well, if I is the square root of negative 1, if I would square both sides of my equation, keeping it balanced, right? So then that would mean I squared is equal. What does a square and a radical do to each other? They cancel each other out. So it's equal to just negative 1. Okay. If you guys move on to like pre-calc and calculus after this class, we talk in those classes not only about I squared, but also like I cubed and I to the 4th. They all come up many, many times. It's not hard. It does come back again. It's really not bad, I promise. Well, I can tell you when stuff is like hard that I know you're going to struggle with versus not hard. And this, not hard. All right, well, good. All right, so since we were talking about multiplying, I took 2 separate radicals and I was allowed to multiply them together to give you 1 radical, right? So would it seem okay then if can I take 1 radical and pull it apart into 2 separate? Is that legal? I can take 2 and put it into 1. Can I take 1 and pull it into 2? Yes, I can. I can. So like on number 1, when I have square root of negative 12, the first thing I'm going to do is pull that out as negative 1 is one of them, and then 12 is the other. Why can I not take the square root of a negative number? Grab your calculator. Type in the square root of negative 25. It is a non-real answer, right? Because when I ask you the square root of negative 25, your calculator is like, I don't know, I can't do that, right? It's a non-real answer. What if I ask you what's the square root of 25? You tell me it's 5 or negative 5. Square root means it's a number times itself. 5 times 5 is 25. What's negative 5 times negative 5? Still 25. So when I'm asking this, I'm asking what number times itself gives me a negative 25? Nothing. I can't, because 2 negatives are going to make a positive. 2 positives still makes a positive. So that's why we can't do this. That's why it's not real. All of our math rules are like, can't do anything with that. So that's why we talk about imaginary. So if I go ahead and start here, I can pull out this. Negative 1 times 12 is still negative 12. I didn't change the value of it. What's the square root of negative 1? Look, I. Yeah, it's in your notes, right? It's I. So this is an I. So right now I have I radical 12. Okay. And then what would you do with the 12? You'd simplify. Yeah, do your factor tree. 4 and 3, 2 and 2. So I have a pair of 2's. So they come out. And I still have an I on the outside. And then I have a leftover 3. That's it. So, I am a lazy mathematician. I told you guys that from day 1. If I can do it in less steps, I'm going to do it in less steps. Is it safe to say, when I see a negative number under my radical, my answer will have an I in it? Do I need to show the step where I separate that negative 1 under a radical before I write out an I? No. If you want to, because it makes you feel better, you go right ahead. I'm lazy. I don't want to do that. Okay, so like right away when I look at number 2, I'm like, oh, look, there's a negative there. That's going to be I radical 45, right? I know the negative. I'm going to pull that out. It's going to become an I. And now I'm just going to simplify the 45. I told you, I's are not hard. So 9 and 5, 3 and 3. So what's the answer to number 2? Good. Pair of 3's, I have an I, and I have a leftover 5. 3I radical 5. Now, a couple things. Every year, somebody goes, can I write I3? Technically, yeah. Would you write X3 or 3X? You'd write 3X, right? It's just how we used to seeing it. It looks weird if you do it the other way. It's not wrong. I will not count it wrong. It just looks weird. Okay? Also, notice my I's have a little bit of a tail on the end of them. Why? It needs to be lowercase. It needs to be lowercase. And I know it's an I, not a 1. I've had students go through doing their work, and they wrote an I, but then they like lost their dot, and they didn't put a tail on it. So then like as their problem progressed, instead of 2I, it became 21, and they just kind of kept going. You lost something there. Okay, so for me, I like the little tail just so I recognize it's an I. Do not make it a capital I, or I will count it wrong. Yeah, because a capital I could be a Roman numeral of 1. It also could stand for interest, and your interest formulas is capital I. So in math, capital letters and lowercase letters, they make a difference. Okay, so this I for imaginary is lowercase. All right, number 3. You should know this one right before. Final answer. 7 I's. If you wrote I7, I would not count that wrong. I would probably snicker a little bit because it looks weird. It does. Yeah, but if you have a perfect square, that's fine. You can just recognize it's perfect, and that's just 7I. so number 4, square root of negative 108. Well, right away I recognize there's a negative, so my answer will have what? An I. So I, radical 108. Oh my. 108 is not perfect, so we'll go ahead and do our factor tree. You can choose to break that down however you see fit. All right, and then do we have pairs? Yeah, got a pair of 2s and a pair of 3s, which give me 6. Don't lose your I. And a leftover 3. So 6I radical 3. Again, I like to jump and skip sometimes when you guys appear to be doing all right. Let's skip 5, jump to 6. Sorry, overachievers. So number 6, right away I recognize there's a negative under my radical, which means there's an I. So I have 5I radical 112. The 5I is just kind of hanging out, right? We're going to ignore him for the time being. Let's do our factor tree on the 112. So I'm going to go 2 and 56, 2 and 28, 2 and 14, just to be obnoxious, and then another 2 and 7. All right, so we have 2 pairs of 2s, right? 2 and another 2. I have a leftover 7. Don't forget the 5I is already out front. So 5I times 2 times 2. Wait a minute. Can I multiply a number with an I with a number that doesn't have an I? Can you multiply 3 times 7x? You can multiply if they're not like terms, you just can't add. So I'm allowed to multiply. Even though this one has an I acts like a variable for the most part. You can multiply if they're not the same. That's okay. So 5I times 2 times 2 is going to give me 20I, and then radical 7. Right, so I can multiply and divide if they're not like terms. I cannot add and subtract unless they're like terms. All right, doing good, guys. Oh, number 7. There's a plus sign in there. All right, number 7. What do you think we should do first? Get rid of the plus sign? Am I allowed to just erase it? I can't just erase it. I actually can't get rid of it. No, not right now. Let's get rid of that negative underneath my radical, though, first. Yeah, very nice. So I have negative 2 plus, I'm just going to pull that I out. So I radical 20. Am I allowed to add negative 2 plus I? No, they're not like terms. I cannot add those. All right, but I can clean up the radical still. All right, we'll do a factor tree on that. 4 times 5, and then 2 and 2. So I have a pair of 2s. And there's still an I. I have a leftover 5. And that negative 2 plus just still kind of follows me down. Can I add negative 2 plus 2I radical 5? J? There's a J on there? Right, one is an I, one doesn't. They're not like terms. I cannot add them. So as far as me simplifying, I'm done here. I know it probably bothers you, like, come on, I want to put some more of that together, but you can't. They're not like terms. All right, let me give you guys a couple minutes. I want you to try 8 and 9 on your own. Okay, 8 and 9. All right, so let's do number 8 first. So first thing, negative under the radical, let's pull that out. Then we can do our factor tree. And then we have a pair of 5s that come out. I have my I, and then I have a leftover 2. So 5I radical 2. Now, number 9. This is why I always ask on this question. So number 8, the first thing I did was pull the negative out from under the radical, correct? Where's the negative on number 9? It's outside of the radical. So is it imaginary then? It is not. Guys, I need to make sure we're clear on that. If there's a negative under the radical, it's imaginary. This negative is not under the radical. It's just like there's a -1 sitting out here. So it's just a number out in front. So I'm going to do my factor tree here. 2 and 4, 2 and 2. Pair of 2's, which comes out. Leftover 2 inside. And then that number is going to just follow me down. So -1 times 2 is -2, radical 2. That is not imaginary because the negative is not under the radical. Okay, if you type that in, -1 or just negative radical 8 in your calculator, it'd give you a decimal. It would not say non-real or not real or imaginary or whatever your calculator told you. Non-real, so to say. Non-real. Non-real means imaginary. All right. So number 10. Ooh, there is a minus sign. Does number 10 have an imaginary part to it? No, it does not. All right, radical 289. Is that perfect? It is 17. So that's just 8 minus 17. Are those like terms I can put together? Yeah, 8 minus 17 is -9. So that one I was able to go one step further and be okay. All right, number 11. Is that imaginary or not? Oh, I hear a yes and a no. It is imaginary. Now, I know we were doing like, when we were doing our exponent properties, if you would have had like 3 minus a -12, you would have changed that to a plus and added, right? However, that negative is held inside that radical. I can't just kind of put it together with another one to make it positive. It doesn't work that way. Radicals are like jail, right? They hold them inside. How do I get this negative out? I put an I out here. So this is 3 minus I times the square root of 144. That negative comes out by bringing the I out. Square root of 144 is 12. So I have 3 minus 12I. Can I put those together as -9I? Why not? He can do it. The look of disgust on his face. I love it. Right, one is an I, one does not. They are not like terms. I am done here. I just want to make sure we can see that difference, right? Number 10, the negative was on the outside. It was not imaginary. So these were just plain old numbers. I can put them together. Here, the negative's under the radical, which becomes an I. And then the one has an I, one doesn't. They're not like terms. I can't go any further. We okay? All right, number 12. Imaginary or not? It is imaginary. So 2, pull out the I. I know, I love that joke, right? Finally, somebody laughs at my funny jokes, right? All right. Square root of 72, is that one perfect? No, it's not. All right, so I'll do my factor tree. Any pairs? Got a pair of 2's. Got a pair of 3's. I got a leftover 2. And then I also had this stuff that was already out there to begin with. So what do we end up with? 12I radical 2. Good. So we talked about multiplying today, and we talked about imaginary numbers. See how they kind of blended together, didn't they? We did it all together. Yeah, I think we're good. Questions on any of this stuff? No? Awesome.